Alright, and here's the video for chapter 6. Let's see, 6.1 is skipped, so we're going to start with 29, which is 6.2. The rate of change of y is proportional to y. When x equals 0, y is 4. When x equals 3, y is 10. What is the value of y when x equals 6? It's been a while, so I'm going to reference the book here. Okay. So when it says the rate of change of a variable y is proportional to the value of y, then it's saying that dy over dt, because rate of change is in respect to time, is equal to ky. Or in other words, it's saying that the derivative is equal to ky written this way. We went through all the process to develop the formula y equals ce to the kt. Now you don't have to start here every time. You can just assume if they say the rate of change is proportional, again, that's what it means to be proportional, rate of change means derivative, that when you integrate it, this is what you're going to get. So if this is the case, then this is the formula we're going to use with our data points. We've got 0, 4, we've got 3, 10, and we're trying to figure out 6 question mark. So what happens when I plug in 0, 4? What information does that give me? And technically you don't have to plug in 0, 4, but I like to see everything kind of working together here. 0 being your t value. Well, k times 0 is 0, e to the 0 is 1, so this informs us that our initial quantity is 4. From there, I'm going to move on to the second data point. What happens when I plug in 10 with the initial value that I know? You can see that the only variable left is k, so this is going to allow me to find my proportionality constant. First, divide by 4 on both sides, always. I'm going to leave it as 10/4. There's no reason for me to actually simplify that. To unravel my exponent here, I have to undo the e with a log whose base is e, and that happens to be the natural log. You can also write log base e, but natural log shows or demonstrates understanding. Natural log of e cancels, and I'm left with the natural log of 10/4 equaling 3k. If you divide both sides by 3, then the result is your proportionality constant. Natural log of 10/4 over 3 is the exact answer, but for context, that is equivalent to approximately 0.305. That's about a 31% growth. So now, and I'm going to number these. That's the first thing we figured out. This is the second thing we figured out. And now the third thing is by taking this t value, we're able to figure out the y. I've got y equaling 4, which doesn't change, e to the natural log of 10/4 over 3. If you want to write 0.305 here, you can, but I would suggest that you actually use the exact value instead, times 6. Those can cancel. And my approximate value, 4e to the natural log of 10/4 times 2. Oh, it's not approximate at all. It's exactly 25. Number 30. Radioactive radium has a half-life of approximately 1599 years. That means after 1599 years, I have half of my quantity, whatever that y value is. After 1,000 years, 1.5 grams of the original amount remains. If there was an initial amount of 6, so they're telling you that C is 6 grams, how much will remain after 3,000 years? Well, here's what I know. Half of that happens or exists after 1599, so I can change 1/2 y to the number 3. And I'm going to go through this process again, but there's no need to go through the initial portion because I'm already given that. So here's what I know for sure. I'm behaving under the equation y equals 6e to the kt. All right. I want to use a point that has information in it, and see if I can solve something from there. So let's see. I'm going to use 1,000 here and show what that looks like. 1.5 equals 6e to the k times 1,000. All right, so 1.5 over 6 equals e to the 1,000k. I think this question gave more information than you actually needed. Apply natural log to both sides. And in the process, divide by 1,000. So k is equivalent to the natural log of 1.5 over 6 divided by 1,000, which is approximately equal to negative 0.0014. I'll go 4 decimals for this one. So I'm going to use that information when I rewrite this formula as 6e to the negative 0.0014t. Again, when I'm doing my calculation, I'm not using negative 0.0014. I'm using the exact to plug in. If you want to store that into the letter k, that will probably be a very useful tool. So I'm going to store this into k so that I know exactly where it is when I need it. Okay? So now if I'm trying to figure out the value at 3,000 years, I plug in 3,000. You can see that now that that's stored, I can type in 6e to the k times 3,000, and I get an exact answer again. 0.09375. Make sure we answered the question. How much will remain? That's how much will remain, that many grams. All right, section 6.3, starting with question number 31. Solve the separable equation dy over dx equals 4 minus y. If it's already told that it's separable, then we know that the basic algebra elements that we use, multiplying, dividing, all that stuff, are going to work to get the x's on one side and the y's on the other. Divide both sides by 4 minus y. And I have to integrate 1 over 4 minus y dy and dx. This is a u sub where 4 minus y is my u. If 4 minus y is my u, then negative 1 is my du. Now it's balanced. This becomes the negative natural log of the absolute value of 4 minus y, and this becomes x. It says to solve for y. In order to do that, I'm going to move this negative over to this side by dividing by negative on both sides, negative 1 on both sides. I feel like the algebra is going to be a little bit easier now. Apply e to both sides, and I'm left with 4 minus y equaling e to the negative x. Just manipulate a couple things to get y by itself. And just a rule of thumb, I multiplied everything by -1 to change the signs here, and instead of starting my statement with a negative, I just chose to bring the constant +4 to the front. And that's it. You can always graph it to make sure that it is, in fact, a reflection over the line y equals x. (32) y prime is equivalent to saying dy over dx. I'm going to try and get it alone. I need to separate my y's and x's, and the only way I can do that is by taking out what they have in common over here and removing it from the quantity. I'm going to leave the x's on the right and bring the y's to the left, meaning that I get 100 over y and x dx. Same as before, this is a u sub 100 minus y. It requires a negative. I'm going to bring the negative over again. Apply E, both sides. And just to do everything in one step, I'm going to move the y over instead. And there we go. This one didn't say solve for y, but if it's possible, I would expect you to do so. (33), kind of the same idea, except now we're given a particular solution, or we're given an initial condition, rather. It says x dy dx. I'm going to move the 3y over. That means I'm going to keep the 3 with the right side. There's no reason to bring it with the y, just to not complicate things as much. If that's difficult to understand, then by all means you can keep the 3 with the y. It doesn't matter. But the x is going to become a denominator. The dx is going to be part of the numerator. Bring the 3 out front. This becomes the natural log of y equals 3 times the natural log of x. Oh, and I've been forgetting my plus c's, so let's go back here. I apologize for that, guys. Starting back at 31. Plus c1. When I take e of that, I can create it to look like c2. And I could just finish my statement by saying c times that quantity. For 32, my plus c would come up right here. I could treat it like c2, and then I can just multiply my entire quantity by c. And then down here, I'm going to bring this 3 up to the x as well. Apply e to all of them, and I get y equaling c e, whoops, I'm getting all in my head. Y is equal to c, and then here the e in the natural log, so cx cubed. Now that's not complete because we were given the initial condition, -3, 2, which means that -3 goes in for x and 2 goes in for y. -3 cubed is -27, so c is equal to 2 over 27. Final answer, 2x cubed over 27, and that's it. 34 x squared plus 4 dy dx equaling xy. Again, I'm going to bring the x's to the right. That gives me dy over y on the left, x over x squared plus 4 dx on the right. This is just natural log. This becomes a u sub that requires a 2 and a 1/2. Natural log of y equals, now that the whole denominator is equal to u du. Bring this up. Apply e, and I get c times the square root of x squared plus 4. If you need to see this, there is a step in between here and here where it would become e to the natural log of x squared plus 4 to the 1/2 times e to the c1. This is the e to the c1, and this is what happens when you have the natural log, or e raised to the natural log of the square root. dy over dx equals x square root of 5 minus x squared. All we have to do is bring up the x. I'm going to let u equal 5 minus x squared. du is negative 2x dx. Right, if I put a negative 2 here, balance it with 1/2 negative. Okay. So then I've got y equaling negative 1/2 u to the 3/2 over 3/2 plus c, or better yet, negative quantity 5 minus x squared to the 3/2 over 3 plus c. Number 36, if you're asked to test whether or not something is homogeneous, then that's when you change f of xy to f of tx, ty. What would happen if I plugged in tx for x and ty for y? My numerator, I can collect my t's and get t squared xy. My denominator, I can simplify that as to t squared x squared plus t squared y squared. I can also collect the t's by undistributing them. And I know that the square root of a product is the square root of each portion of the product. So this is equal to t squared xy over the square root of t squared times the square root of x squared plus y squared. I can take the square root of this monomial, leaving just t. My result, I can cancel one of those t's with that denominator, and I have t times my original quantity. The reason that's important is because, first of all, it's homogeneous if I can get t of any degree times the original. So it's homogeneous. That we know. We also know that the degree of t is whatever the t is that's left over. If the t's gone completely, then it's 0. But right now, that's a t value of 1. If we weren't able to factor out the t, then it would be not homogeneous. 37, we're testing homogeneity again, so we've got f of tx, f of ty, or f of tx, ty. The t's can cancel inside the absolute value, and I'm left with my original equation. Because I have the original intact, I know it's homogeneous. But because I don't see t, then my degree is 0. Now we're told that it's homogeneous, so I don't have to test it, but I know that there's different rules that apply now that it is homogeneous. First of all, I'm going to see if it's separable. And I can tell early on that there's not going to be an opportunity for me to get all of my x's to one side and all of my y's to the other. So the alternative is to use a temporary distraction, I guess. I'm going to let my y equal vx. It's some sort of function of x. That means that dy is equivalent to v dx plus x dv. Some of you would probably prefer writing it in a different order, like it'd be the derivative of v, which is the dv, times x. And that would be the way that you learned it probably from the first part of Calc 1. But that's what I'm going to use for my substitution, just to be in line with, just to be predictable, I guess. I'm going to take the y out and put vx in its place. I'm going to take the dy out and put v dx plus x dv in its place. And my goal is to be able to get this to be separable. I also think it's important to write these in alphabetical order because it's very easy to lose some of the algebra in the process. Okay, I get v squared x squared dx plus vx cubed dv equaling x squared dx plus v squared x squared dx. I'm going to put all of my x's on one side, all of my v's on another, or at least my dx's and my dv's, which means I'm going to move this dx over because all the other dx's are on this side. And you can see that that's going to cancel. All right, let me rewrite this. I've got vx cubed dv and it's equivalent to x squared dx. All right, my dx is on the right, so I'm going to keep that consistent and bring the x cubed over to it. Integrate, and I get v squared over 2 equaling natural log of x plus c. However, v was not the original letter that we should have been using, so I'm going to resubstitute v with what v is equal to, and that's y over x. This question doesn't say to solve it for any particular variable, so I could leave it like this. I don't like fractions within fractions, so I am going to clean that up and write it as 2, or y squared over 2x squared equaling the natural log of x plus c. You could solve for y, or you could solve for y squared, but it's not necessary. And that's the end of chapter 4, or chapter 6. So again, if you have any specific questions that you want to ask me separately, by all means do. We're going to pick up chapter 8 on Monday, chapter 9 on Tuesday. Wednesday I have algebra office hours. If we need Thursday, we can do that, but my plan is to distribute the final on Thursday and collect it on Friday. But we'll feel that out from there.